Okay, we just got done multiplying monomials, but whenever you want to multiply binomials, then what you can do is you can use the FOIL method. So you may remember that. You can only use that when you multiply two binomials. So when you do that, here for 5a, we're going to take 2 radical 3 times a 3, which will give us a 6 radical 3. And then we got to take the 2 radical 3 times a negative radical 3. Well, when you do that, you have a 2 times a 1 on the outside, which gives you a 2. Radical 3 times radical 3 ends up becoming a radical 9. As you can tell, radical 9 is a perfect square. So what happens is whenever you multiply a radical by itself, what you're going to be able to do is you're going to be able to basically simplify and just cancel out whatever your radical is and just make it whatever's underneath there. So if you multiply radical 3 times radical 3, you're really just going to get a 3 without the radical. Next thing we need to do is multiply our 3 radical 5 times our 3, which will give us a 9 radical 5. And then when we multiply the 3 radical 5 times a negative radical 3, that's going to give us a negative 3 radical 15. So when you multiply, or when you look at these problems, you can add anything together that has the same exponent, or same radical, same number underneath the radical, if you don't have to simplify. Well, we do actually have to simplify. We're going to have to simplify the radical 9. So this is going to end up and give us a problem where we get 6 radical 3. That's a nice 6. 6 radical 3. Oh man, that's just going to bug me. Let me clean this up a little bit here. Alright. 6 radical 3 minus, well, if this becomes a 3, you're going to have a 2 times a 3, which is 6, plus 9 radical 5 minus 3 radical 15. And since none of those numbers underneath the radical can be added together, this just ends up being your answer. So a nice, ugly, long answer with 4 terms. If you look at B, you might notice that this actually is a special binomial times binomial. This is a difference of squares. So what I'm going to do is I'm going to take my 4 radical 2 times 4 radical 2, but I'm just going to square it. So I'll say 4 radical 2 squared. And this is going to come in handy in one of the next couple examples, so this is why I'm doing the shortcut. Minus, and then you take the 7 times 7, or you write it as 7 squared. So now the big thing is when you take a 4 radical 2 times a 4 radical 2, you have to square the 4 and square the radical 2. So if you square the 4, that gives you a 16. If you square a radical 2, that gives you just 2, because the square will cancel out with the radical. Another way to look at this is if you actually write it out. If you have a 4 radical 2 squared, 4 radical 2 squared means you're going to have a 4 radical 2 times 4 radical 2. So that means you're going to get a 16 when you multiply those. And then you take radical 2 times radical 2, you get just a square root of 4, which ends up becoming a 2. So back to the problem. So when you square the 7, you get 49. So if you have a 32 minus 49, you are going to end up and get a negative 17. The big thing you should notice about when you multiply a binomial time or a difference of squares is you lose all of your radicals. So when you multiply a radical times itself, then you lose all your radicals and you get just a whole number, and that's what we're going to be doing in the next example.